Astronomy, The Science of the Heavenly Bodies by David Todd. Astronomy, a Living Science. Like life itself, we do not know when astronomy began. We cannot conceive a time when it was not. Man of the early Stone Age must have begun to observe sun, moon, and stars, because all the bodies of the cosmos were there, then as now. With his intellectual birth, astronomy was born. Onward through the childhood of the race, he began to think on the things he observed, to make crude records of times and seasons. The Chaldeans and Chinese began each their own system of astronomy. The causes of things and the reasons underlying phenomena began to attract attention, and astronomy was cultivated not for its own sake, but because of its practical utility in supplying the data necessary to accurate astrological prediction. Belief in astrology was universal. The earth set in the midst of the wonders of the sky was the reason for it all. Clearly, the earth was created for humanity. So too, the heavens were created for the edification of the race. All was subservient to man. Naturally, all was geocentric or earth-centered. From the savage who could count only to 5, the digits of one hand, civilized man very slowly began to evolve. He noted the progress of the seasons. The old records of eclipses showed Thales and early Greek how to predict their happenings, and true science had its birth when man acquired the power to make forecasts that always came true. Few ancient philosophers were greater than Pythagoras, and his conceptions of the order of the heavens and the shape and motion of the earth were so near the truth that we sometimes wonder how they could have been rejected for 20 centuries. We must remember, however, that man had not yet learned the art of measuring things, and the world could not be brought into subjection to him until he had. To measure, he must have tools, instruments. To have instruments, he must learn the art of working in metals, and all this took time. It was a slow and in large part imperceptible process. It is not yet finished. The earliest really sturdy manifestation of astronomical life came with the birth of Greek science, culminating with Aristarchus, Hipparchus, and Ptolemy. The last of these great philosophers, realizing that only the art of writing prevents man's knowledge from perishing with him, set down all the astronomical knowledge of that day in one of the 3 greatest books on astronomy ever written, the Almagest, a name for it derived through the Arabic and really meaning the greatest. The system of earth and heaven seemed as if finished, and the authority of Ptolemy and his Almagest were as holy writ for the unfortunate centuries that followed him. With fatal persistence, the fundamental error of his system delayed the evolutionary life of the science through all that period. But man had begun to measure. Geometry had been born, and Eratosthenes had indeed measured the size of the earth. Tools in bronze and iron were fashioned closely after the models of tools of stone. Astrolabes and armillary spheres were first built on geometric spheres and circles, and science was then laid away for the slumber of the Dark Ages. Nevertheless, through all this dreary period, the life of the youthful astronomical giant was maintained. Time went on, the heavens revolved, sun, moon, and stars kept their appointed places, and Arab and Moor and the savage monarchs of the East were there to observe and record, even if the world mind was lying fallow, and no genius had been born to inspire anew that direction of human intellect on which the later growth of science and civilization depends. With the growth of the collective mind of mankind, from generation to generation, we note that ordered sequence of events which characterizes the development of astronomy from earliest peoples down to the age of Newton, Herschel, and the present. It is the unfolding of a story as if with a definite plot from the beginning. Leaving to philosophical writers the great fundamental reason underlying the intellectual lethargy of the Dark Ages, we only note that astronomy in its development suffered with every other department of human activity that concerned the intellectual progress of the race. To knowledge of every sort, the medieval spirit was hostile. But with the founding and growth of universities, a new era began. The time was ripe for Copernicus and a new system of the heavens. The discovery of the New World and the revival of learning through the universities added that stimulus and inspiration which marked the transition from the Middle Ages to our modern era, and the life of astronomy, long dormant, was quickened to an extraordinary development. It fell to the lot of Copernicus to write the second great book on astronomy, De Revolutionibus Orbium Celestium. But the new heliocentric or sun-centered system of Copernicus, while it was the true system bidding fair to replace the false, could not be firmly established except on the basis of accurate observation. How fortunate was the occurrence of the new star of 1572 that turned the keen intellect of Tycho Brahe toward the heavens. Without the observational labors of Tycho's lifetime, what would the mathematical genius of Kepler have availed in discovery of his laws of motion of the planets? Historians dwell on the destruction and violent conflicts of certain centuries of the Middle Ages, quite overlooking the constructive work in progress through the entire era. Much of this was of a nature absolutely essential to the new life that was to manifest itself in astronomy. The Arabs had made important improvements in mathematical processes. European artisans had made great advances in the manufacture of glass and in the tools for working in metals. Then came Galileo with his telescope, revealing anew the universe to mankind. It was the north of Italy where the Renaissance was most potent, recalling the vigorous life of ancient Greece. Copernicus had studied here. It was the home of Galileo. Columbus was a Genoese, and the compass which guided him to the Western world was a product of deft Italian artisans whose skill with that of their successors was now available to construct the instruments necessary for further progress in the accurate science of astronomical observation. Even before Copernicus, Johann Müller, better known as Regiomontanus, had imbibed the learning of the Greeks while studying in Italy, and founded an observatory and issued nautical almanacs from Nuremberg, the basis of those by which Columbus was guided over untraversed seas. About this time, too, the art of printing was invented, and the interrelation of all the movements then in progress led up to a general awakening of the mind of man, and eventually an outburst in science and learning which has continued to the present day. Naturally, it put new life into astronomy, and led directly up from Galileo and his experimental philosophy to Newton and the Principia, the third in the trinity of great astronomical books of all time. To get to the bottom of things, one must study intimately the history of the intellectual development of Europe through the 15th and 16th centuries. Many of the Western countries were ruled by sovereigns of extraordinary vigor and force of character, and their activities tended strongly toward that firm basis on which the foundations of modern civilization were securely laid. Contemporaneously with this era, and following on through the 17th century, came the measurements of the Earth by French geodesists, the construction of greater and greater telescopes, and the wonderful discoveries with them by Huygens, Cassini, and many others. Most important of all was the application of telescopes to the instruments with which angles are measured. Then, for the first time, man had begun to find out that by accurate measures of the heavenly bodies, their places among the stars, their sizes and distances, he could attain to complete knowledge of them and so conquer the universe. But he soon realized the insufficiency of the mathematical tools with which he worked, how unsuited they were to the solution of the problem of three bodies, sun, earth, and moon, under the Newtonian law of gravitation, let alone the problem of n bodies mutually attracting each other, and every one perturbing the motion of every other one. So the invention of new mathematical tools was prosecuted by Newton and his rival Leibniz, who, by the way, showed himself as great a man as mathematician. Taking mathematics, wrote Leibniz, from the beginning of the world to the times when Newton lived, what he had done was much the better half. Newton was the greatest of astronomers who, since the revival of learning, had observed the motions of the heavenly bodies and sought to find out why they moved. Copernicus, Tycho Brahe, Galileo, Kepler, Newton, all are bound together as in a plot. Not one of them can be dissociated from the greatest of all discoveries. But Newton, the greatest of them all, revealed his greatness even more by saying, "If I have seen further than other men, it is because I have been standing on the shoulders of giants." Elsewhere he says, "All this was in the 2 plague years of 1665 and 1662, for in those days I was in the prime of my age for invention, and minded mathematics and philosophy more than at any time since. At the time, he was then but 24. All school children know these as the years of the plague and the fire, but very few, in school or out, connect these years with two other far-reaching events in the world's history: the invention of the infinitesimal calculus and the discovery of the law of gravitation. We have passed over the name of Descartes, almost contemporary with Galileo, the founder of modern dynamics, but his initiation of one of the greatest improvements of mathematical method cannot be overlooked. This era was the beginning of the golden age of mathematics that embraced the lives of the versatile Euler, equally at home in dynamics and optics and the lunar theory, of Lagrange, author of the elegant Mécanique analytique, and Laplace of the unparalleled Mécanique céleste. With them and a fully elaborated calculus, Newton's universal law had been extended to all the motions of the cosmos. Even the tides and precession of the equinoxes and Bradley's nutation were accounted for and explained. Mathematical or gravitational astronomy had attained its pinnacle. It seemed to be a finished science. All who were to come after must be but followers. The culmination of one great period, however, proved to be but the inception of another epoch in the development of the living science. The greatest observer of all time, with a telescope built by his own hands, had discovered a great planet far beyond the then confines of the solar system. Mathematicians would take care of Uranus, and Herschel was left free to build a bigger telescope still and study the construction of the stellar universe. Down to his day, astronomy had dealt almost wholly with the positions and motions of the celestial bodies. Astronomy was a science of where. To inquire what the heavenly bodies are seemed to Herschel worthy of his keenest attention also. While a knowledge of the construction of the heavens has always been the ultimate object of my observations, as he said, and his ingenious method of stargazing was the first practicable attempt to investigate the construction of the sidereal universe, he nevertheless devoted much time to the description of nebulae and their nature, as well as their distribution in space. He was the founder of double star astronomy, and his researches on the light of the stars by the simple method of sequences were the inception of the vast fields of stellar photometry and variable stars. The physics of the sun, also, was by no means neglected, and his life work earned for him the title of Father of Descriptive Astronomy. While progress and discovery in the earlier fields of astronomy were going on, the initial discoveries in the vast group of small planets were made at the beginning of the 19th century. The great Bessel added new life to the science by revolutionizing the methods and instruments of accurate observation, his work culminating in the measure of the distance of 61 Cygni, first of all the stars whose distance from the sun became known. Wonderful as was this achievement, however, a greater marvel still was announced just before the middle of the century. A new planet far beyond Uranus, whose discovery was made as a direct result of mathematical researches by Adams and Leverrier, and affording an extraordinary verification of the great Newtonian law. These were the days of great discoveries, and about this time the giant of all the astronomical tools of the century was erected by Lord Rosse, the Leviathan reflector with a speculum 6 feet in diameter, which remained for more than half a century the greatest telescope in the world, and whose epochal discovery of spiral nebulae has greater significance than we yet know, or perhaps even surmise. The living science was now at the height of a vigorous development, when a revolutionary discovery was announced by Kirchhoff which had been hanging fire nearly half a century, the half-century, too, which had witnessed the invention of photography, the steam engine, the railroad, and the telegraph. 3 simple laws by which the dark absorption lines of a spectrum are interpreted, and the physical and chemical constitution of sun and stars ascertained, no matter what their distance from us. Huggins in England and Secchi in Italy were quick to apply the discovery to the stars, and Draper and Pickering, by masterly organization, have photographed and classified the spectra of many 100,000 stars of both hemispheres, a research of the highest importance which has proved of unique service in studies of stellar movements and the structure of the universe by Editing and Shapley, Campbell and Kapteyn, with many others who are still engaged in pushing our knowledge far beyond the former confines of the universe. Few are the branches of astronomy that have not been modified by photography and the spectroscope. It has become a measuring tool of the first order of accuracy, measuring the speed of stars and nebulae toward and from us, measuring the rotational speed of sun and planets, corona and Saturnian ring, measuring the distances of whole classes of stars from the solar system, measuring afresh even the distance of the sun, the yardstick of our immediate universe, measuring the drift of the sun with his entire family of planets 12 miles every second in the direction of Alpha Lyrae, and discovering and measuring the speed of binary suns too close together for our telescopes, and so making real the astronomy of the invisible. Impatient of the handicap of a turbulent atmosphere, the living science has sought out mountain tops and there erected telescopes vastly greater than the Leviathan of a past century. There the sun in every detail of disk and spectrum is photographed by day, and stars with their spectra and the nebulae by night. Great streams of stars are discovered, and the speed and direction of their drift ascertained. The marvels of the spiral nebulae are unfolded, their multitudinous forms portrayed and deciphered. And their distances? And the distances of the still more wonderful clusters? Far, inconceivably far beyond the Milky Way. And are they island universes? And can man, the measurer, measure the distance of the mainland beyond?